All right, let's talk about one of the biggest, most frustrating problems in AI right now. The fact that sometimes it just lies, it makes stuff up. So the big question is, could something as simple as geometry be the answer? So let's just start with this number, 28.6%. You might be wondering what that is. Well, according to one study, that's how often a top-tier AI model, something like GPT-4, can just hallucinate when you ask it for something simple like references. We're talking nearly 1 out of every 3 times it's confidently making things up. That right there is a huge trust problem. And just to make sure we're all on the same page here, a hallucination isn't just the AI getting a small detail wrong. No. This is when it creates content that sounds totally believable, totally fluent, but it's completely fabricated. It's not just incorrect, it's like creatively incorrect. And look, this isn't just about your AI bot messing up trivia. These hallucinations pose huge risks when we're talking about high-stakes applications. Think about it. Medical diagnoses, legal advice, financial planning. In those fields, one made-up fact could have really serious consequences. So the question is, what can we possibly do about this? Okay, so this is where it gets really interesting. A team of researchers from the University of Oxford has come up with this super clever approach. Instead of trying to crack open the AI's code and read its mind, which is often impossible, they're using geometry. Yep, geometry, to teach the AI to recognize when it's not sure about something. So how in the world does that work? Let's get into it. The big idea here is actually kind of beautiful in its simplicity. They basically treat every single possible answer to a question as a point on a map of the AI's thoughts, if you will. And by looking at the shape that all those possible answers form, they can literally measure how confident the AI is. So here's how it breaks down step by step. First, you get the AI to spit out a whole bunch of different answers for the same question. Then, you plot all of those answers on this, map of ideas. Step 3, you find the answers that are way out on the edges, the extreme outliers. And finally, you measure the size, the volume of the space that those outliers create. What's so cool about this is that it works for any model, even a black box one, where you have no idea what's going on inside. All right, so we have this map of ideas, and it's a volume. What now? Well, it's not just a pretty picture. This whole concept is the foundation for a really powerful two-part system. It's designed to first spot when the AI is confused, and then, and this is the important part, to actually pick the best answer out of the bunch. So they're really measuring two different kinds of uncertainty. On one hand, you've got what they call global uncertainty. That's the big picture view. Is the model overall just totally confused by the question you asked? But then they zoom in and look at local uncertainty. And that's about asking, okay, what about this one specific answer? Is this one any good? Let's talk about that first part, the global score. They call it geometric volume, and it's pretty intuitive. If the AI is really unsure, its answers are going to be all over the place, right? That creates a huge, spread-out territory with a large volume. But if it's confident, all its answers will be clustered tightly together, making a really small volume. So a big volume? That's a huge red flag that a hallucination might be in there somewhere. Okay, so spotting uncertainty is great. That's a huge step forward, for sure. But here's the real question. Can this method actually fix a wrong answer? I mean, it's one thing to know the AI is confused, but the real game changer would be actually correcting the mistake. Well, let's see how this plays out in a real test. In their experiments, they often started with a scenario where the AI's first, most obvious answer was just a flat-out hallucination. Exactly the kind of thing we're trying to stop. And this is where the second tool, the geometric suspicion score, comes in. This thing is so clever. It looks at every single answer the AI generated and gives it a score based on a few things. Is it an outlier, way different from the others? Is it really far from the general consensus? Is it built out of weird, uncommon ideas? It's basically a system that's designed to find the answer that just doesn't quite fit in. And here's the payoff. After the system calculates that suspicion score for every single answer, the solution is incredibly simple. They just pick the one with the lowest score. And what they found was, by doing that, they could often just toss out the initial hallucination and pull out a correct answer from that very same batch of ideas. It's amazing. Okay, this all sounds pretty incredible in theory, right? But does it actually work in the real world? To find out,
The researchers really put this thing through its paces, on some very complex, very high-stakes data. And the test that really mattered the most was on medical questions and answers. I mean, this is a field where you can't afford to be wrong. Accuracy is absolutely everything. So just take a look at this. This is the baseline. Without this geometric check, a model like GPT 3.5 Turbo was hallucinating on over 60% of real-world medical questions from a specific dataset. Let that sink in. More than half the time, it was giving bad medical information. That's just terrifying. But now, look at this. This is the impact of their system. After they applied their method to just pick the least suspicious answer, the hallucination rate dropped all the way down to under 30%. They literally cut the number of errors by more than half. That is just a night and day difference.
So, talking about an absolute reduction of 31.3 percentage points. In the world of AI safety and making these things more reliable, an improvement that big, it's absolutely massive. So, what's the big takeaway from all of this? Basically, this geometric approach gives us this amazing two-in-one tool. You've got geometric volume, which gives you that big picture look at whether the AI is confused. Then you've got geometric suspicion, which lets you zoom in and rank each answer. And the best part is this works on pretty much any model out there. And it's a huge deal for those super important fields, like medicine. And really, when you get right down to it, this is more than just a cool academic paper. What we're seeing here is the construction of a foundation. A foundation for building AI systems that we can actually start to trust with our most critical tasks, whether that's diagnosing an illness or handling our finances. And that leaves us with a really fascinating thought to chew on for the future. If we can use something like geometry to teach an AI to know when it's uncertain, to give it a little humility, what's the next human-like quality we should try to teach it?